Hello and welcome to this video. I find remote control via app generally bad. For remote control of devices, I will use a haptic input device that is suitable. Cars are steered with a steering wheel, planes are flown with a joystick, etc. I won't control my car with an app either, but with the steering wheel and pedals. This is a comment by Baumeister 81 on a German blog that I translated to English with Google Translate. And that's also a perfect new project to test the new hub-to-hub possibilities of Pybricks. But first, let's get to the intro. I've used the LEGO Technic 42124 off-road buggy as the vehicle for this project because I didn't want to build a whole new vehicle. It was meant for a fast test. The remote or steering wheel was made solely from the LEGO Spike Prime kit. I tried to mimic the controls of a car. One motor is used as a steering wheel by using the rotation or angular position sensor in the motor, and the gas pedal was made with a force sensor. And of course, there is the hub that reads the sensors and forwards the signals. Conveniently, the hub also has two arrow buttons, which can be used as gear switch or, to be more precise, as direction change buttons. That's necessary because the force sensor can only read values between 0 and 10 Newton. There is no change direction option with the sensor itself. The final model of the steering wheel doesn't look very pretty, but that wasn't the goal. My main interest was to test if the Pybricks hub-to-hub communication actually works, and I wanted to stick with parts from the Spike Prime set. And these are pretty special by themselves because of the color choice. Let's get to the interesting part, the program. For the programming people among us, you can also take a look into the video description and jump to the next timestamp if you can't code in Python, because of course I use Pybricks, so the main code will be in Python. My goal for the program was that the remote should work completely independent of any apps. That's the reason why I use Pybricks. It can be used to write and download Python programs for the hubs. There's no PC or smart device or app necessary after the initial download. For this application, every controller and every vehicle needs its own program. The controller reads the sensors and sends the data to the vehicle, where the received values get translated to motor movements. The data transfer is possible by using the newest broadcast option of Pybricks. It can send a signal to a selected channel that every hub within the range receives. Sadly, only a total of 26 bytes can be sent. Yes, bytes, not kilobytes or megabytes. That means that we can only transfer a text with 25 letters or 5 numbers per message. It's a limitation of the Bluetooth low energy broadcast commands. Luckily, 2 numbers are enough for one vehicle. This option is only available in the current beta version of Pybricks. Version 3.3 is required. I already wrote a program to remote control the buggy with the LEGO Powered Up remote, which I could use as a base for this project. The calibration sequence for the front wheels could be used directly. Now, instead of the remote, the Bluetooth low energy commands are received from the other hub. Values for speed and the direction can be directly used as an input for the motors, and the steering needs an additional factor which comes from the calibration sequence. Then I just had to install the Pybricks firmware on the Control Plus hub and upload the program. The program for the remote that uses the Spike Prime hub was completely written from scratch. First of all, the direction of the vehicle gets changed by pressing the buttons of the hub. Next, the angle of the turning wheel and the force of the force sensor are being read. The value of the force sensor has to be multiplied by 10 because the total speed of the motor can be up to 100%. Additionally, the direction has to be multiplied with the speed value. That way the car will drive forwards with positive values and backwards with negative values. For both values, speed and direction, the sign is being switched because of how the buggy is built. As a last feature, the steering wheel has a sequence to move back into angles between -100 degrees and 100 degrees if it moves further than that. That's because otherwise the wheels of the buggy would turn too far, and the angular values can jump to a value of -180 degrees when they reach an angle of 197 degrees. That's something that I don't want, so I simply move the motors back into the wanted area. I had to install the Pybricks firmware and upload the program to the Spike Prime Hub 2. After that, the buggy can be controlled with a self-made turning wheel. The complete process, including building the turning wheel, testing and fixing errors, took about 2 to 3 hours, and what should I say? The program works as it should. You can find the complete program in my German language blog that's linked in the video description. At this point, I want to note again that this was a project to test the new Bluetooth Low Energy broadcast option of Pybricks. I think that a remote like this is very unpractical in a case like this. Half of the fun from a remote controlled vehicle comes from following the vehicle, and that's something that's not easy to do with this turning wheel. Normally I would still suggest to use the powered up remote, but it can be a useful feature for bigger mocks with more complicated remote controls. Now we can see an example program with a similar functionality written in the Powered Up app for everyone that can't code in Python. In this case, the remote hub has to be hub 1 and the buggy has to be hub 2. Of course, you can't use the Spike Prime hub with the Powered Up app at this point. You will have to use another Technic hub or City hub. And of course, the Powered Up app has to run on the smart device while the remote is being used. That leads us to the end of this video. I'd like to know your opinion on this project in the comments. Do you agree with the code from the beginning that you would prefer a fitting remote, or are you good with more classical controlling devices like gamepads? Also, what would you love to see in the Powered Up app in the future? Thanks for watching, see you in the next video, and bye.